All right, let's move on here. Let's think about this next problem. If you read that carefully, what this says is that we have a positive linear association. That's basically the same thing as positive correlation with the amount of what? With the amount of sodium found in a hamburger, all right, and calories. So what we're saying is it finds that fat calories in hamburgers have a positive linear association with the amount of sodium. Okay, so if we were to think about this, let's think about something other than fat and sodium, just to kind of get our minds around things. Let's think about the amount of hours that you study and your test grade, right? Okay, so this would also have a positive association because as the number of hours studies you study goes up, the number of the grade increases. So it's the same way of saying that the fat calories in hamburgers have a positive association with the sodium found. Okay, so basically what we're saying is the number of hours, the grade in our has a positive association with the study of number of hours you study. So your grade has a positive association with your study. So if we want to kind of connect the dots there, in the same way, we would say this. Okay, if fat calories have a positive association with sodium, the first thing we're saying is fat. That right there is my y axis. So these are my fat calories. Okay, and then that is positively correlated with the amount of sodium that I found, or that we have in our that we find in our hamburgers. Well, we know that we have a positive correlation, so this is what our graph is doing. So now that we have that kind of visual understanding of what's going on, let's come back here and let's read our answer choices. Low amounts of sodium in hamburgers indicate a high number of fat calories. Now, that doesn't match up because low amounts of sodium would be in this area right here. Okay, those that would not have high amounts of calories. That would be low calories. Okay, remember this is fat calories here. Put a CAL as well. Okay, so it's definitely not A. All right, how about B? High amounts of sodium. So over here, high amounts of sodium cause high amounts of fat calories in hamburgers. Okay, so high amounts cause high amounts of fat calories. That looks like it could work. Let's see if we. So far, B looks like a viable answer choice. Let's keep going just to make sure. From there, hamburgers with low amounts of fat calories tend to have low amounts of sodium. Now, if you want to see the difference between those two questions, you want to then go back and recognize, hey, there was a very key word in answer choice B. The word was cause. Do we know for sure that the sodium is causing the calories? And we actually don't. So, on second thought, I'm going to go back and I'm going to say no. It's not going to be B because we don't know for sure that that's what's causing it. Just might be the correlation, but not necessarily the cause. So C is more and more looking like the viable choice because low amounts of sodium tend to have, that's the key word there, that's correlation, tend, like probably or typically, low amounts of sodium. And that is true. The low amounts of fat calories tend to have low amounts of sodium. That is the case. Letter D would be wrong because it says low amounts have high sodium. That is not the case. So there you go. Be very careful when you're thinking through that one. B nearly threw myself off as well. The key word that made that wrong, once again, was the word cause. We don't know the cause. We just know that they're correlated or that they're related to each other. All right. Let's jump in here. I want to talk you through this one real quick because if we're going to create a line of best fit that mirrors or that models this data, you need to think about a couple things. The first thing I want you to think about is the fact that these years, it is not necessary to put in the 190, okay, 1990, the year 1990, as the year that, as the actual number 1910. So do not type the number 1910 into your calculator, okay? What you really want to think about is you want to think about the year 1990 as the year that you're beginning, because it says as the number of farms decrease in the United States, the average size of the remaining farms has grown larger, okay? So you can see that what we're looking for here is we need to basically say, okay, if this is the year, then what would this be as far as an x value goes? Well, this is going to be time 0, okay? So 1990 is going to be time 0, which 1920 is 10 years later, so that's going to be time 10. 1930, 10 years later, so that's going to be time 20. So this is time 30, time 40, time, in that case, 49. Be careful there. Then that one would be time 59. Okay, and this would be time 68. All right, and then this would be time 77. And then that would be time 87. So really what we're plugging in our calculator, the safest way here to plug this in your calculator would be to plug in these numbers here as our x. So in L1, we're plugging in those numbers. So in L1, we're going to plug in those numbers right there. Take 1 second here. Testing. All right, so we're back up here. So I had technical difficulties there for a second. All right, so let's keep moving. What are we plugging in for the L2, our y values? Our y values would be these guys right here, okay? So those are going to be your y values that you're plugging in. So take a second, press pause, plug those into your calculator, see what you end up with, and go from there. Once you've done so, this is what you'll be looking at, and you'll start to create your lines of best fit. Start to think about what will year 2000 be. So you should have already found your line of best fit here, whatever that ended up being. Now, think about what the average will be in the year 2000. So remember that 1910 was year 0. Okay? So think about this now. The year 2000, okay, would be what? How many years would that be? Well, that would be the year 90. So this is the value. You're going to look for this in your table. All right, look in your table, go down to in the X column, find the number 90, and that's going to be your answer there. Then same thing for 2010. For 2010, you're going to look for X equals 100. Okay, what was the average acreage in 2010? And then last but not least, what was the average in 1810? Why can we explain this? If we go backwards, think about that. 1910 was year 0. So if 1910 was year 0, then 1810 would be year negative 100. And you'll see that when you do that, you're actually going to end up with a negative acre. If you end up with a negative acreage, you're going to say, hey, is this reasonable? No, that's definitely not reasonable, because that doesn't make any conceptual sense at all. You can't have a negative acreage, okay? If you would, go ahead and also find the residual for 1930. So a quick reminder that when you're finding the residual for 1930, you're going to find what was the actual acreage in the year 1930, and then you're going to subtract the predicted. What was your predicted acreage in 1930? So go ahead and make that happen and keep moving on to the next lesson. Keep up the good work.